So this is my update after taking my third exam in number theory. This pretty much closes out the course. Then I'm going to spend a couple of weeks studying for the final. And so I'm going to show you guys the notebook that already has all the exam 2 materials, but also exam 3, and then the exam 3 study materials. So I'll take that aside and just go over this notebook. I'll try not to show too much of my arm while you see this. So in this notebook, the last time we talked, I showed all the work that I had done to study for the second exam. All of these pages are really study pages for the second exam, and I have shown these before. I'll just briefly show them again. Things having to do with multiplicative functions, lots of Legendre symbols. I ended up doing a ton of Legendre symbols. Just ended up being a lot more fun than I thought they would be. Yeah, so yeah, I've already shown this before. But then also, yeah, more Legendre symbols. I really got into them. Some primitive roots from last time. But then also, and then the formula review from last time from exam 2. But then picking up on the new material, I started with the lectures for Diophantine equations. And yeah, that was fun. The professor chose to add a lot of content for Gauss sums. They all involve a character, which is really something that comes from properties of an abelian group. Then you sum all these characters. The characters can be like Legendre symbols. A lot of times the sum gives you 0. Sometimes it doesn't. It's linked to the primitive roots of unity. And so you're summing over those, and it's got a geometrical. You can look at it as a circle, all the prime numbers, or if it's for a prime, the number of roots of unity. So if it's 3 is prime. So I did a lot of digging on Gauss sums, but I still think, this is my opinion for this course, that this material should be taken out, and instead the course should have dealt with partition functions and Fur's diagrams, all of the beautiful stuff. Because I feel that that material is more like your basic number theory material. Whereas this is interesting, but it's not as accessible. It definitely is not in any of the books that I have. Yeah, it's not in Rosen, it's not in Nevin, or Niven. I always mispronounce his name, sorry Niven. Yeah, it's not in any of those books. It's definitely not in Burton. So more Diophantine equations, rational points on the unit circle. Did a fair amount of that. That was very interesting. It came out in one of the homeworks, but it did not come out in the exam. Then the problems for Diophantine equations. Many of them. And I did some where I went back, and I even made some videos for the channel where I went back and I set them up, and I even did some continuous fractions for Diophantine equations. It's kind of like a 3-fer, because you do a Diophantine equation, then when you compare the 2 primes, if it is 2 primes, you get you have to do an Euclidean algorithm. Then the result of the Euclidean algorithm can be expressed as a continued fraction, as a finite continued fraction. So very interesting stuff. Had this problem of m is equal to 2 to the x to the 5th minus 9 to the y to the 5th in mod 11. And when you do it in mod 11, you find out that the values for x and y are always plus or minus 1. So you do all the combinations, and then you get all the possible values for m. Very interesting. At first, I did a lot of going around in circles with the problem, until I finally went like, oh, this is all just going around in circles for the problem. Lots of algebra that I didn't need to do at all, until I finally figured it out. Then you can do all the values. Yeah, more rational points. Then more Diophantine equation work for the homework, for the homeworks. Could have done a better job here, but I got close enough. And so that was for Diophantine equations. Then I had this equation, 1 over x square, 1 over plus 1 over y squared equals 1 over z squared. Find the integer solutions for it. That turned out to be very interesting. And yeah, it turned out to be very interesting. So I think I got them all, but I was close. The instructor in her grading was like, well, you didn't find them all, but I found at least some. And boy, it was really hard to figure out how that worked. Sums of squares, lots of sums of squares, either where you allow one of the sums to be 0 or when you use only natural numbers. Those are really two separate problems. This is the one where all for the natural problems. When you start doing 4 of them, there are cases when it cannot. These are the no. And so up to 33 you find several cases of numbers that cannot be expressed as a sum of 5 squares. But then after 33 everything is. And there's a proof for that. It's one of the homeworks. Yeah. More sums of squares. More Diophantine equations. Yeah, continue to work on the homework. This is all for that homework problem. And I used Jupyter Hub until I figured it out equation-wise. I didn't have to use Jupyter Hub to figure it out. Or figure out the ones where I could find some solutions. Yeah. Yeah, sums of squares. Then we get into continued fractions where it's really fairly straightforward. It's really just a bunch of formulas. I had a lot of fun with that. So much fun that I actually, as I was practicing for the exam, almost every morning, early morning before work, I would just do a couple of continued fractions. And I was able to remember the formulas. I was ready in the exam to actually derive some of the formulas because I remembered everything. But I was not asked. All the continued fractions in the exam were fairly simple. Of course, the square root ones give you infinite repetitions, and there's a way to check the number. There's a way to expand it out, expand out the alpha, work in alpha, come up with a quadratic equation in alpha, solve it, and then when you put it back in, you get the actual value that you started with. So, and then there's also this method of a sub j is equal to p sub j plus square root of d over q sub j, which eventually goes in the direction of Pell's equation, which was not covered in this course. But I did remember this. I went back and I did some problems using this methodology. It gives you the same values. And I even made a video for the channel. But the issue that I'm encountering is I need to keep learning, and I'm busy and I have a day job. And so the number of videos that I'll be making is limited. I can't do like 100 videos on something, even though I really want to, just because it would be fun. They don't get that many hits, so it's not like it matters, but just saying. So all things continued fractions. And yeah, I just had a lot of fun. They're just a lot of fun. Just a ton of fun. He went back and did some more Gauss sums. I wish he'd just done partition functions. And then here we have the homeworks and the problems from the book, additional problems. Yeah, I really had a lot of fun with continued fractions. Just a lot. This became like the Legendre symbols. I just did a whole ton of them. So this thing's coming apart. And then I'll show the other book. And then in this case, this is where I do all my, and I made some of the videos using this book. I showed it already, where I show primes, pick up a bunch of random primes. Looked up Mordell's equation from Keith Conrad, but it never came up in an exam. It's the y squared equals x cubed plus a number, and then you shift the number around. and there's a bunch of different types of solutions and ways in which a specific Mordell equation does not have a solution. Very interesting. I read it all, but it did not come up. Found this handout on that really helped me with Gauss sums. It was great. This is a great handout. I don't have the author to mention who it is, and I wish the author had put his or her name on it. But anyways, so yeah, it explains cyclotomic polynomials, learned about them, working with the nth roots of unity and how they're linked to Gauss sums. Very good stuff. This is really good stuff. But I still would have preferred partition functions instead. Then, yeah, more of that handout. Formula reviews. I was ready to work on proofs in the exam that did not come up. I did study them well. More Gauss sums reviews, more continued fraction review for the theorems themselves, more Gauss sums. It did not come up in this exam, it was only in the homework, and then a ton of continued fraction practice. Just oodles and oodles and oodles of continued fraction practice. Some of them I've put as videos in the channel, and I'll make maybe a couple more. Not too many, because I need to move on. The show must go on for me to learn more math, and the show will be some linear algebra and tons of real analysis. All of 2023, I think it's going to be the real analysis show. So I'm going to do some more videos, but not that many on number theory, because I wanna close out number theory and move on to real analysis mostly.